trigonometry. Um, so last week we finished the harmonic motions, the phase difference. Actually, in your textbook, it should be about the basic foundation for trigonometry, but I will skip all of that because I think you already have the foundation for trigonometry. Instead, I will review. Uh, it's called uh, the composed trigonometric functions. Okay, so this is also for helping the calculus part. I believe in calculus, you need to derive the sine and all the trigonometric inverse, right? So before we going to derive, as you have been try to derive this trigonometric inverse before, let me review what is the basic, the concept. Okay. So if you are asking to write sine cosine inverse x as the in algebra with x as variables, okay, for this domain, okay, then how you write the sine cos inverse in the algebra. Of course, now we are see that okay, we have restricted domain. Okay, I rarely mentioned in calculus class that the inverse of the trigonometric function, it has some specific domain. Okay, because if you are doing it outside the domain, then the whole thing become undefined, right? So can you write this sine cos inverse x? But first, okay, inverse of trigonometry. What does that mean? Cos inverse x. What's the point of this? Remember, inverse is a switching between domain and range. Switch the domain and range, right? So if your trigonometric related to angle, okay, like for example, sine 30 is half, right? That means if we have the inverse, sine inverse half is 30. Okay? So do you agree that this is actually our angle? Angle, right? Okay. That's the if you are forgetting what the inverse in trigonometric means, try to remember some easy. I think special value is the easiest one to. I believe you all memorized the special angle, right? 0, 30, 45, 60, 90, right? At least those five, right? In sine, cosine. If you forget the tangent, that's okay. You just divide sine and divide by cosine, right? Okay. So let me write let cos inverse x is equal to uh, let's say theta. Okay. Let's say theta. Okay. So I can conclude because that is my cos inverse, then my cos theta is x, right? That's the implication of the inverse, right? And then, as I mentioned many times, okay, in the calculus class also, draw the triangle. And then maybe theta is here. Okay. And then what is cosine? This side, right? You can say this adjacent. Let me write also to review, okay? Usually we say adjacent. This is, and this is the hypotenuse, okay? Cosine is adjacent divided by hypotenuse, right? Okay. So in this case, okay, I will write in the red color. The cos theta is x. It's actually x over 1, okay, to get the idea what this x means in terms of triangle. So x and 1 here, okay? So x and 1. And the other side, because of the right triangle, we can say that this other side will be 1 minus x squared, okay? So let me back to what our original questions. Sine cos inverse x. So if we are dealing with the cos inverse is theta, then the actual terms for the sine cos inverse is just sine theta. Agree? Okay. Then we can just write the sine theta based on our triangle here will be the opposite sides and over the hypotenuse, right? And it will be 1 minus x squared, okay? Okay, if we have, let me get you tangent cos inverse x, okay? What will happen if we have tangent cos inverse x? Because we already have the cos inverse as theta, then tangent should be uh, tangent theta is opposite sides divided by the adjacent sides, right? And you get 1, okay? Okay. What will happen if I have cosine cos inverse x? Cosine cos inverse. Hmm? Who? Yes, x. Okay, x. Okay. To remind you that the property of inverse, okay, if you have f inverse x, this will be x. Okay. If you have f inverse and then f x, this should also be the same x. Okay. You can switch the inverse, but because you are plugged in the functions that mirror to the inverse, the result should be your domain, right? For x. Okay. You can prove that also if you want. So try this, and the inverse is, let's say it's x squared. The inverse should be square root of x. If you put the square root of x and then squared, it's x, right? Makes sense, right? Okay. So this will be true. Okay, that's the a little bit reviewing, and I will going through the triangle now. Let's make the triangle A, B, C. Okay, and usually, I think in elementary school, the sides in front of this symbol, if this is A capital, then this will be the small a, right? The sides. Usually in math, we are doing like this. Okay? So this will be B, this will be C. Okay. If I want to look for the area of triangle ABC. Okay. Anyone remember how to find? Hmm? Yeah, that's also correct. Another way, yes, using sine, right? So let me make a line here to make it easy to follow. Let me make line, because if you have a triangle, basically triangle is half the base and the height, right? And let me make this height is h. Okay. So area of triangle will be, if I'm using C as my base, then it will be half times C times h. And we can change the C or change the h, okay, into our sine formula. Okay. Sine, let's say sine A. Let me write sine A is h over b, right? This b is h. So my h, oh, I will directly moving here. So half c, let me write b sine A. Okay. And the same goes by if we have uh, another triangle. Okay. Imagine that, and then I cut the line. Now it's from C, and then it's C. But I think my triangle is not really good. Okay. Uh, Imagine you cut B, and imagine this is right triangle. Okay. To so you can easily see observe. Okay. Imagine this B it's become right triangle. Okay. I can also have half A B sine C, and also half AC sine B. Of course, if you are using this triangle, you will have additional lines to help you to get the right triangle. Okay, but you can make the triangle when you cut from B, C, and A, you will have a right triangle. Okay, I think here you need to have like here, but yeah, let's make this all three as our area. Okay, so the point that I want to show is, let me write uh, AB sine C. Okay, I want to make uh, proof with sine here that I can canceling this half altogether. And if we looking at this particular, these two areas, I can write this as, or let me just divide by ABC, all divide by ABC, okay? Divide by ABC, so directly divide, I think that should be okay. So divide by, so I will get sine C over C, sine B over B, sine A over A. Okay. This is what we call the law of sine. Okay. Okay. Um, let me write another triangle should be, okay. Um, so make the same, I think, ABC. Okay. Now, similar triangle with previous slide. if you want to make ideal triangle from the previous slides, make the triangle when you are cutting line from each angle. It's making right triangle at the base. Okay? That will be perfect. But if not, that's fine. Okay. Okay. So see this triangle here. Okay. Let me write. This is B sine A, as we previously mentioned, and this side will be B cosine, right? Okay. This is 90-degree. Let me make the uh, this side is x. Okay. Or it's not necessarily need to be x. I just write the c minus b cos. Okay. Now see this triangle here. Okay. Okay. Let me write the a squared is equal b squared plus c minus what should be b sine a squared plus c minus b cosine a squared. Okay. Let me expand the c minus b cos a. Okay. So I will get the this will be b squared sine squared a plus c squared minus 2bc cos a plus b squared cos squared a. Okay. Now we have b squared sine squared a, b squared cos squared a. The sine squared plus cos squared is 1, right? So I can, or let me move the b squared sine squared a plus cos squared a, and then plus c squared minus 2bc cos a. Okay. So this sine and cos is 1, sine squared plus cos squared, right? Okay. Oh, I didn't mention how to prove it later. So b squared plus c squared. So this will be a squared equal b squared plus c squared minus 2bc plus a. You can also approach with other bc that you will have the pattern. So b squared will be a squared plus c squared minus 2ac cos b, and c squared will be a squared plus b squared minus 2ab cosine c. Okay. Before I'm writing this down, I actually don't remember what is this. Okay. So actually, you will see the pattern when you are understanding the how to derive this formula, and then you get okay. So a, and then this is b, and this is c. This is also bc, but the angle should be the same as the in the front of the sides. Okay, that's how you are trying to understand the concept. Okay, not just basically memorization without any concept. Okay? So this is what we call the law of cosine. Okay? Okay, and I forgot to start with the easiest proof for this trigonometry. Let's say A, B, C. This is A, C, B. Okay. Let me write sine theta is A over B. Cos theta is what? C over B. And tangent theta will be A over C. Okay. And Pythagorean theorem. Okay. Uh, B squared is A squared plus C squared, right? B squared, A squared plus C squared. Okay. Let me divide all this. Divide with 1 over B squared. Okay. So this will be 1. This will be A squared B squared plus C squared B squared, right? I can also rewrite this as 1 A over B squared and C over B squared, which is our sine and cos, right? So whenever you forget the sine cos identity, use the triangle, use the Pythagorean theorem. Okay. And you can prove this as sine squared theta plus cos squared theta is equal 1. Okay. 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 Now, let me copy this triangle first. And let me just write this as uh, area is sine A. Okay. Now, if this is area, okay, let me square this both equations. So A squared is 1 over 4 B squared C squared sine squared. And then I will get 1/4 b squared c squared 1 minus cos squared a. Let me write this one more time. Okay. Let me make notations, equation 1, and see what our law of cosine. Let me just copy this. And based on our law of cosine, I want to change, okay, this cos A here. I want to change through this law of cosine, okay? So let me write in blue. So cos A will be it's b squared plus c squared minus a squared over 2bc. Okay, and then let me plus 1. So 1 plus 2bc. So 2bc to okay. This 2b and c. Okay. So 2bc b squared c squared is our quadratic formula, right? So this will be what? B plus c squared should be minus, sorry, minus a squared divided by 2bc. Then we move here. Uh, b plus c squared minus a squared. Okay, make this as x. Okay, if you have x squared minus a squared, you can write this as x plus a x minus a. Right? Let's do the same thing with b plus c. So it will be 2bc. So b plus a, b plus c plus a, and then b plus c minus a. Okay, and then this is this 1 plus cos a, or let me write this one more time. Let me copy this. This is 1 plus cos a. So 1 minus cos a will be b plus c should be, wait, okay. Should be A plus B plus C and A minus B plus C. Oh, no, no, no. Should be A plus, this should be A minus. Okay. I'm skipping some parts here, but it should be correct, right? So my A squared is 1 over 4, A squared, B squared. To BC, to BC. So A plus B plus C plus A, B plus C plus A, B plus C minus A, B plus C. Okay, seems complicated, but okay. So let me finish this. A plus B plus C, A plus B minus C, C plus A minus B, C minus A plus B. Divided by 2, 2, 2, 2. Should be, okay. And A squared will be the perimeter minus C, S minus B, S minus A. Or you can say the area is square root of this. Okay, so if you have any triangle, you don't know the exact angle, but you know you have A, B, C. You can use this formula to find the area. Okay, basically you just to solve this all the way. So you will get A, B, C, A, B minus C, C plus B minus B. Okay, and you get the S is the perimeter, which is the A plus B plus C, the S. Okay. Okay, let me continue this part tomorrow, and going forward to finishing the trigonometric. Okay. Any questions?